Hello viewers, in today's class we are going to discuss one important conceptual integral from definite integrals, right? So here we have to find the value of this integral which is from -1 to 1 2 times signum function of x minus 1 divided by the fractional part function of x and absolute value of x minus 1, right? So here one interesting thing about this definite integral is that here we have three functions, right? Actually this integrand is a combination of three functions. The first one is the signum function, and the second one is the fractional part function, and the third one is the absolute value function, right? So let us start now. Before proceeding further, let us first discuss the definition of these three functions, right? Because once we are well acquainted with the definition of these three functions, we can easily integrate this function, right? So now we know that signum of y is equal to +1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to -1 whenever y is less than 0, right? So here we have x minus 1, so y can be taken as x minus 1. So signum of x minus 1 is equal to +1 whenever x minus 1 is greater than 0, and signum of x minus 1 is equal to 0 whenever x minus 1 is equal to 0, and signum of x minus 1 is equal to -1 whenever x minus 1 is less than 0, right? So here we have x is greater than 1 because we solve this inequality. Here we have x is equal to 1, and here we have x is less than 1, right? So this is the first function, which is our signum function, right? Now let us come to the second function, which is our fractional part function, and we know that the fractional part function is equal to x minus the greatest integer x, right? So this is the definition of fractional part function, right? Here if we take, say, x is equal to we can take 0.5, then the value of the fractional part of 0.5 is equal to 0.5 minus greatest integer 0.5, and we have 0.5 minus here the value of greatest integer 0.5 is simply 0, so we have 0.5, right? Similarly, we can take say 1.5, that is equal to 1.5 minus greatest integer 1.5, and this is 1.5 minus the value of greatest integer 1.5 is equal to 1, right? So we have 0.5, right? So this is how we calculate the value of the fractional part function, and the third function is our absolute value function, right? So we have mod of x minus 1, and from the definition of absolute value function, we know that mod of x minus 1 is equal to plus x minus 1 whenever x minus 1 is greater than or equal to 0, and mod of x minus 1 is equal to negative of x minus 1 whenever x minus 1 is less than 0, right? So this can also be written as minus x plus 1, right? And here x is greater than or equal to 1, and here x is less than 1, right? So once we have seen the definition of these three functions, let us now take the real number line, right? Now if we take the real number line, then we see that here we have signum of x minus 1 is equal to 1 whenever x is greater than 1, right? So let us take the point 1 here, and we have the lower limit as minus 1 here, right? So let us plot the lower limit and the upper limit over here in the real number line, and we see that 0 lies between minus 1 and 1, and 0 lies somewhere here, right? Okay, now if we closely look at the inequalities here, see here we have x is greater than 1, right? So this part of the real number line is x greater than 1, which we are not going to use, right? Because here we have to integrate just from minus 1 to 1. So this part of the real number line is of no use to us, right? So we'll leave it, right? Okay, and x is equal to 1 here, and then x is less than 1. So this part, this whole part is x less than 1, right? Okay, so now let us take this integral I. Now we can break this integral as a sum of two integrals, right? Because see here we have minus 1 to 0, then we have 0 to 1. So why we are breaking it at 0? Because see here we have the fractional part function x, and fractional part function is written as x minus greatest integer x. So we have to integrate this greatest integer function at the integral points, right, or at the integers, right? Okay, so that's why we are breaking this integral into two integrals, right? So we have I1 plus I2. Now I1 is from minus 1 to 0, and we have the function 2 times signum of x minus 1 over fractional part of x plus mod of x minus 1 dx, and here we have from 0 to 1 2 times signum of x minus 1 over fractional part of x plus mod of x minus 1 dx, right? Now we can replace this fractional part of x by this expression, so we can rewrite it as 2 times signum of x minus 1 over x minus greatest integer x plus mod of x minus 1 dx, and here we can write 0 to 1 2 times signum of x minus 1, and here we have x minus greatest integer x plus mod of x minus 1 dx, right? Okay, now we see that here when x lies between minus 1 to 0, then obviously all the values of x are less than 1, right? So the value of signum of x minus 1 is obviously equal to minus 1, because x is less than 1, right? Because we are integrating from minus 1 to 0, and all the values of x which lies between minus 1 and 0 are obviously less than 1. So signum of x minus 1 should be taken as minus 1. So here we have 2 times minus 1 dx, and here in the denominator we have x minus. Now see here we have greatest integer x, and when x lies between -1 and 0, then the value of greatest integer x is equal to -1, right? So here we have -1, and for mod of x minus 1, see, we are integrating or we are having the lower limit and upper limit as -1 and 0. So we have this interval, and in this interval x is less than 1, right? So when x is less than 1, then the value of mod of x minus 1 should be taken as minus x plus 1. So here we have minus x plus 1, right? Now come to the second integral. We have 0 to 1, and again we see that when we are from 0 to 1, then obviously x is less than 1. So again, for signum of x minus 1, we have here minus 1, right? And in the denominator we have x minus, and the value of greatest integer x is now, see here, x lies between 0 and 1. So the value of greatest integer x is equal to 0, right? So here we have 0, and for absolute value of x minus 1, again we have to use minus x plus 1, because x lies between 0 and 1, and when x lies between 0 and 1, x is less than 1. So here we have minus x plus 1, right? So viewers, once we have arrived at this step, now we can easily solve these two integrals. So now we have the first integral is from -1 to 0, and we have minus 2 dx, and we have x plus 1, then we have minus x plus 1, and then we have 0 to 1, and we have minus 2 dx, and we have x minus 0, and we have minus x plus 1, right? Okay, so now we can further simplify it. So this x and this x get cancelled. So now we have from -1 to 0, and we have minus 2 dx, and here we have 1 plus 1 2, and then we have 0 to 1 minus 2 dx, and here we have 1, right? So now here 2 and 2 get cancelled, and we have from -1 to 0 and minus 1 dx, and here we have minus 2 and 0 to 1 dx, right? So now taking this negative sign outside the integral, we have -1 to 0 dx, and here we have minus 2 0 to 1 dx, and now the integral of dx is x, so we have x -1 to 0, then we have x 0 to 1, right? So now we can substitute the limits. So now we have 0 minus -1, and here we have 1 minus 0, right? So this is minus minus plus, so we have -1 here, and here we have -2, so this is -3, right? So viewers, the value of this integral is -3, and we have seen that this is a very interesting integral, which is a combination of three important functions in mathematics, and the functions are signum function, fractional part function, and the absolute value function.